This physics question talks about a collision at an entry ramp. So a car stops on an entry ramp waiting to merge onto a highway, and a truck comes up behind it and hits it in making that car go at 20 meters per second into the highway. And so the question asks us what the initial velocity is for the truck in order for that car to move into traffic at that velocity. We can first use the conservation of momentum formula, that's this one, to relate the initial and final velocities, because the momentum of a system is constant if there are no external forces acting on the system. And so since there's only the two vehicles, there are no other forces. So from there, we know that the velocity initial of the car is 0 because it's at rest. So this portion of the equation goes to 0. So for our conservation of momentum formula, we are left with this, and that's the mass of the truck times velocity of the truck initial is equal to the mass of the car times the velocity of the car final plus the mass of the truck times the velocity of the truck final. So what you're seeing in this whole equation is the initial of the whole system, the initial momentum of the entire system, which is the two vehicles. So we have the momentum initial of the car, the mass times the velocity initial of the car, plus the mass times the velocity initial of the truck. Then we have the mass times the velocity final of the car, and the mass times the velocity final of the truck. And so that gives us our total momentum. And so we end up with just using this formula. For any elastic collision, we would use this equation. And we know it's elastic because the car and the truck bounce away from each other, so to speak, which represents that both momentum and kinetic energy is conserved. And this equation can show that for any elastic collision between two objects, the relative speed is the same before and after the collision. And since the relative velocity is in the opposite direction after a one-dimensional collision, so the objects move together, collide, and then move apart. So what this means is that the initial velocity is the same as the final velocity, except this is in the opposite direction. So that's why there's an extra minus sign there. So after removing all the variables, that become 0, and we combine the conservation of momentum formula with this equation. And we want to solve this net equation. We're looking for this of the two together. So in order to do that, we have to multiply both sides of this equation by the mass of the truck. And so whenever we do that, we get this. So we have V2 initial, which is the velocity of the truck initial, that is multiplied by the mass of the truck, and we multiply the other side by the mass of the truck as well. And so once that's multiplied out, we get this equation, and that's just, it brings the mass to both sides. And so we're given this. Then, to find this net equation down here, we combine it, or we add it to our conservation of momentum equation that we found earlier. And so that would cancel these two out because it's minus and plus here. And then we combine mass of the truck, so there's two of those, and then velocity of the truck initial, and then we're left with this net equation. And then we're looking for the initial velocity of the truck. So in order to find that by itself, we need to divide both sides by 2mt, or 2 times the mass of the truck, to separate this variable. And so in doing so, we find that velocity of the truck initial is equal to the velocity of the car final times the masses of both the truck and the car divided by 2 times the mass of the truck. And so whenever we plug in all of our values that are given, that's these, then we get that the car was moving at a rate of 17.5 meters per second whenever it hit the rear end of the vehicle.